Everyone, welcome to today's tutorial. In today's tutorial, we'll discuss a few numerical questions from mensuration of plane figures or mensuration of quadrilaterals. If you have not watched the previous videos, please make sure that you have watched the previous videos, then only watch this video on mensuration of quadrilaterals. Okay, today we will discuss a few numerical problems from exercise 18.2, which is on page number 329 of your textbook. Okay, so let us directly go to question number 1. So the question number 1 reads as each side of a rhombus is 13 centimeter. So we'll try to correlate it with the figure. The figure is not given to you in the question. You need to draw the figure on your own. Okay, each side of a rhombus is 13 centimeter. Now what is a rhombus? Rhombus is a quadrilateral. Quadrilateral means any closed figure having 4 sides. So rhombus is a quadrilateral in which all of its sides are equal and the diagonals are not equal. Okay, don't get confused between a rhombus and a square. In a square, all the 4 sides are equal and the diagonals are also equal to each other, but in a rhombus, though all the 4 sides are equal to each other, but the diagonals are not equal to each other. In this question we have a rhombus. Okay, so each side of a rhombus is 13 centimeter. That means all the sides of this rhombus is 13 centimeter. So I have constructed a rhombus A, B, C, D, and each side I have labeled just 13, 13, 13 and 13, because that is one of the property of rhombus, that is all the sides of a rhombus are equal to each other. Okay, let's read it further. And one of its diagonal is 10 centimeter. Find the length of the other diagonal. That is your first part of the question, and the second part, the area of the rhombus. Right. Okay, now if we are to draw the diagonal, so A, B, C, D is a rhombus. So if we join A and C, that will give us our first diagonal, and if we join B to D, that will give us our second diagonal. Okay, so the length of one of the diagonal is given. So let us say the BD, the length of BD is given. So that means this entire whole thing is 10 centimeter. Okay, now the other property of rhombus says that the diagonals, they intersect each other at 90 degree. That means the diagonals, they intersect each other, and that means they bisect each other, and wherever they bisect each other, the angle made between them is 90 degree. It's a right angle. That means both the diagonals are intersecting here. So at this point, let us label it as O. So what does that mean? That means BO and OD will be equal to each other. That means BO will be 5 centimeter and OD will also be 5 centimeter, because the diagonals, they bisect each other. So the entire diagonal is 10 centimeter. That means half of the diagonal will be 5 centimeter. Again, the next half will be 5 centimeter. Okay, the next diagonal is AC, but we don't know the length of the other diagonal. That is what we are supposed to find in Roman 1. So AC, so let us take the half part of the diagonal. The half of the diagonal AC will be AO. So if you could see, I have just put a small question mark. That means we don't know that. Okay, so let us concentrate on this part of the figure only. Okay, if you look at this part of the figure only, we have a right angled triangle form here. Okay, right angled triangle form here. So this becomes our hypotenuse, AD becomes our hypotenuse, AO becomes our perpendicular, and OD or DO becomes our base. So we are interested to find the length of AO. In order to find AC, we need to know the length of AO first. That means we'll be using the Pythagoras theorem here. Okay, so hypotenuse square is equal to perpendicular square plus base square. So the hypotenuse in this right angle triangle AOD, if I am to make this right angle triangle separately here, that means this is our AOD. So this is our 5, this is our 13, this is our question mark, we don't know, and this is a right angle triangle. So our hypotenuse becomes 13, our base becomes 5, and perpendicular we don't know. Okay, so hypotenuse square is equal to perpendicular square plus base square. So perpendicular square is 13 square, hypotenuse is 13 square, perpendicular is AO, and our base is OD square. Okay, so let us substitute the values. 13 square will give us 169, AO is unknown, plus your base is 5 square, 5. Okay, 169 is equal to AO plus 25. So you transpose the 25 to the left hand side. 169 minus 25 will give you 144. So root of 144 will give us 12. So what is the length of AO? The length of AO is 12 centimeter. Okay, but we need to find the length of the entire diagonal. Okay, so AC is the diagonal. So what is AC equal to? AC will be equal to AO plus OC. So AC is equal to AO plus OC. Now if AO is 12, if this part is 12, that means the other part will also become 12 OC. That means if AO is 12, our OC will also become 12. Okay, so AC is equal to AO plus OC. So AC is equal to 12 plus 12, so AC is 24 centimeter. That means the length of the other diagonal is equal to 24 centimeter. Okay, I hope things are clear till here. So before we proceed to the second part of the question, please have a look. Okay, after we are done with the diagonal, okay, now let us see how do we proceed to find the area of the rhombus. Okay, so area of the rhombus is given by half into the product of its diagonals. So we are well aware how many diagonals do we have. We have two diagonals here. That means what is the area? The area is given by half into product of the diagonals. That means if you multiply both the diagonals into half will give us the area of the rhombus. So area is equal to half into product of its diagonals. So area is equal to half into what are our diagonals? AC and BD. So what are our diagonals? AC, this is our first diagonal, and BD, this is our other diagonal. So area is equal to half into AC into BD. So area is equal to half into AC. We just calculated AC has 24 centimeter, and then BD is given in the question, which is 10 centimeters. So we cancel, 2 will go 12 times, so we are left with 12 into 10. So area is equal to 120 centimeter square. So this will give us the area of the given rhombus. Okay, I hope so the second part is also clear to you. So we just apply the formula for area for rhombus, and both the diagonals, we have both the diagonals. We just multiply the diagonals and divide it by 2, and that gives us the area of the rhombus. Okay, so please have a look. Now, so once we are done with question number 1, now let us take some more examples. So the first figure we took was a rhombus. Now let us see how do we go about when our figure is a trapezium, for example. So let us see question number 2, and let's see how do we go about it. Okay, now let us discuss the next question, question number 2 from exercise 18.2. But before we discuss this question, there's one term you need to understand. What do you mean by cross section? Okay, what is the meaning of cross section? Okay, so let us try to understand what is the meaning of cross section. Suppose if you have any figure, okay, any solid figure, if you cut it across, okay, if you cut it in a straight line, whatever you can see, that is your cross section. For example, if you have a watermelon, okay, watermelon is a spherical in shape. Now if you cut it through at the middle or anywhere, okay, if you cut it through, so whatever you can see from the front, that is the cross section. So what is the cross section of a watermelon, or what is the cross section of a sphere? It is a circle. Okay, in the same way, if you have say a cuboid or shoebox, okay, and if you cut the box at the middle or at the center or anywhere, and if you just see it from the front, so whatever figure you see, that is the cross section. So what is the cross section of a cuboid? The cross section of a cuboid is a rectangle, or it may be a square also. So what does cross section means? If you cross section it, that means if you cut it and then if you see it from the front, that is the meaning of cross section. Why am I explaining you what is the meaning of cross section? Is because in this question we are to deal with cross section. Okay, so there is a swimming pool, okay, and then we have taken the cross section. That means this is a swimming pool, okay, this is the side views, okay, we have sliced the swimming pool lengthwise, and whatever we see from the front, that figure is here. Okay, you just imagine the school swimming pool, okay, towards the shower room it is shallow, and towards the dining hall type it is deep. Okay, so this is the shower room side, and this is the dining hall side. Okay, so if here it is shallow here and it becomes deep here. Okay, so I'm cutting it this way, I'm slicing it from the front, and we are looking from the front. So this is your cross section of the swimming pool. Okay, now the cross section of a swimming pool so formed here is a trapezium. Okay, so this length is given as 1.5 meter, this length is given as 8 meter, and this entire length is given as 14 meter. Okay, so these two sides will be parallel to each other. That means BC and AD will be parallel to each other. That means these two sides, if you produce it, they will never meet each other. Okay, so these two sides are parallel to each other, and the distance between the two parallel sides, this acts as our height. Okay, you might think that that is the length of the swimming pool, but the distance between the two parallel sides, because this acts as the two parallel sides, so the perpendicular distance between the two parallel sides, this acts as the height of the trapezium. Okay, so this figure so formed is a trapezium. So our question is, okay, let us read through the question once. The cross section ABCD of a swimming pool is a trapezium. So this is the cross section of a swimming pool. Okay, you are viewing it from the front. You have sliced it, okay, lengthwise, and then you are viewing it from the front. Its width AB is equal to 14 meter. Depth at the shallow end is 1.5 meter, and deep end is 8 meter. The deep end is 8 meter, and at the shallow end is 1.5 meter. Find the area of the cross section. That means we are supposed to find the area of the cross section. That means we are supposed to find the area of the trapezium. Okay, please try to correlate this problem with this figure first, and then we'll go to the solving part. So please have a look. Okay. Now I hope the figure and the solution, I hope you have established a relation between these two. What is the meaning of cross section, and how these two are the parallel sides, and how this 14 meter becomes your height. Okay, now we'll be needing this when we are actually calculating the area of the trapezium. Okay, let's see this. So area of the trapezium is given by half into sum of parallel sides into the height. Okay, this is the symbol of parallel sides. Okay, so area of the trapezium is equal to half into sum of the parallel sides into height. Okay, all these formulas and relation has been already discussed in the previous video tutorials, so please watch the previous video tutorials if you have not watched the previous video tutorials. All these formulas have been discussed in detail in the previous tutorials, right? Okay, so area of the trapezium is equal to half into sum of parallel sides into the height. So what did I tell you? What are our parallel sides? AD and BC are our parallel sides, and what is the height? AB becomes the height of this trapezium. Okay, now area is equal to half into sum of the parallel sides. That means AD and BC. Sum means we need to add. Okay, so AD plus BC. So AD plus BC are the parallel sides into multiplied by the height. So the height of the trapezium becomes, AB becomes the height of the trapezium. So area is equal to half into the length of AD is 1.5, the length of BC is 8 into 14, the length of AB is equal to 14. So from here is just calculation. So area is equal to half into 1.5 plus 8 gives us 9.5 into 14. We cancel, 2 will go 7 times 14, so 2 7s are 14. 7 into 9.5 will give us 66.5 meters square. So this gives the area of the cross section of the swimming pool, or the area of the trapezium A, B, C, D. I hope the working is clear to you. Please have a look. Now once we are done with this question number 2, okay, let us take one more example wherein things will become more clear to you. Okay, so let us take question number 3. Question number 3 is also based on trapezium. Okay, so the area is given and the parallel sides are given, and one of the parallel sides is missing. So let us see how do we go about question number 3. Now let us see how do we go about question number 3. So this question is from the same exercise 18.2. okay, let us read through the question. The area of a trapezium is 360 meters square. The distance between two parallel sides is 20 meter, and one of the parallel sides is 25 meter. Find the other parallel side. Okay, find the other parallel side. Okay, so there is no figure given in the question. Let us try to make a figure. So since it is a trapezium, let us make the figure of a trapezium. Okay, so our trapezium is A, B, C, D. Okay, so ABCD is a trapezium. So what are our parallel sides? AB and CD. So AB and CD, these are our parallel sides. So one of the parallel sides is given as 25 meter, and we are supposed to find the other parallel sides. I have given a question mark, and the distance between the two parallel sides is given as 20 meters. So as I was telling you, as I was explaining you in the previous question, the distance between the parallel side is nothing but the height. It is called the height of the trapezium. Okay, so the distance between the two parallel sides is given as 20 meter. So we have just labeled this as A, which is the height, which is 20 meter. Okay, so based on the question, I have made a figure of a trapezium, and what are the information given? Area 360, AB, one of the parallel side is unknown, so we give a question mark. Then AE is 20 meter. What is our AE? It is the height of the trapezium. And then CD is 25 meter. One of the parallel side is 25 meter, so 25 meter. Okay, so before we proceed for the actual calculation, please take a look and just try to correlate the question and the figure whatever I have made here. Please take a look. Okay, now once the figure is clear to you, now let us go for the calculation. Now we know area of a trapezium is given by half into sum of the parallel sides into the height. Okay, so area is given to us 360 in the question. 360 meters square, this is given in the question, is equal to half into sum of the parallel sides. So what are our parallel sides? AB and DC or CD are our parallel sides. AB plus CD into height. So what is the height? AE becomes the height of the trapezium. So we just need to substitute the values here. So 360 is equal to half into AB is unknown, we don't know, plus the length of CD is 25 into AE, the height is 20. So 2 will go how many times? 10 times. So 2 tens are 20. So 360 is equal to AB plus 25 into 10. Now we cross multiply the 10 down here to the numerator, to the denominator. This is in the numerator, so this cross multiplies down to the denominator. So 360 divided by 10, so the 0 and the 0 cancel out each other, so we are left with 36 is equal to AB plus 25. So we are interested with the AB, so we will transpose the 25 plus 25 to the left hand side. So 36 minus 25 is equal to AB, so AB is equal to 11 meter. So what is our AB? AB is nothing but the other parallel side. So one of the parallel side is 25 meter and the other parallel side will be 11 meter, and the height of the trapezium is 20 meter. So for all this information, the area is equal to 360 meters square. Okay, I hope the working is clear to you. Please take a look. Now once we are done with the question number 3, okay, we'll stop here today. If you have any questions, if you have not understood any of the concept of whatever questions we discussed today in this tutorial, please clear your doubts when we are having our online classes. Okay, these are simple straightforward sum wherein you just need to apply the formulas of the quadrilaterals. Okay, as I mentioned you right in the beginning, if you have not watched the previous videos on areas of quadrilateral, please watch those videos, then only this will make sense. Okay, because all these formulas, whatever formulas we use today, all these formulas have already been discussed in the previous video tutorials. Okay, any doubt on any of these questions, please feel free to clarify your doubts when we are having our online classes. That's all for today. Bye for now.